Okay, so can you see my screen?
Yeah.
Great.
Perfect.
Okay. So good afternoon, good evening, everyone, depending on where you are from. So today I will focus on solar fishing boats as a solution, which the objective is to solve the problems faced by small fishermen or fishing community in India and across the world using renewable energy. This is built on the capability and experience gained over the years of building solar electric boats for public transport, leisure boats, and similar applications. So based on those success and experience, we have shifted to this sector to offer a solution that solves a big problem which they face. Now, as we all know, just to set the context, India is one of the largest, it's the second largest fish producer in the world. And we make about 142 lakh tons, and it contributes about 1% of the GDP. Now, we export more than 10 lakh tons of fish, earning about 30,000 crore forex. So this is a context we have to set on this fishing community. And if you see the 5 large states, obviously they are all coastal states. These are those 5 large states. And what is a common context for all of them is like, in total, there are about 4 million or 40 lakh fishing folks in the country. And 61% of them are below poverty line. And they are mostly the ones who use these small fishing boats, which are typically 10-meter or 30-foot boats. And they use this 9.9 HP Yamaha or Suzuki or various OBMs running petrol on kerosene. So this is the market segment which we are addressing or trying to offer a solution. Now, currently what they do is they go to the sea for daily fish catching, which is they spend about 5 hours running time, which could be 8 to 10 hours of operation time. And they go about 240 days in a year. So that's their operation cycle. So this translates to, it's about 3 liters of fuel, petrol mostly, per hour, and that's 15 liters per day. And that's the total consumption, which is 3,600 liters per year. So there are 2.5 lakh such boats across India, from Gujarat to Kerala and down and to the east side to West Bengal. So this in total consumes almost 1 million liters of petrol kerosene in a year. And from an emission perspective, that is about 2 million tons of CO2 per year. Now, these boats come at a price about 3 lakh, including the boat and the petrol OBM. There are some subsidy element. This price is after that. And then they spend for this, today's price is, the petrol is slightly higher price, just over 100 rupees. But roughly after subsidy, they spend about 3 lakh per year. This is their current operating scenario. Now, this includes some amount of subsidy in fuel as well. Now, the problem they face is all related, interrelated problem in the sense that of this sector. One is this fuel price is obviously increasing, but that itself, it was a few years back, it was 65 rupees. Now it's closer to 100. So that's a bigger issue for them because most of their operating expense is fuel. Now, you also know across the world, there is an issue of a diminishing catch because of overfishing and various big fishing vessels catching all the fish, so that these small fishermen are forced to go further and further to get their catch, which in turn means more fuel consumption and thereby the difficulty in surviving. So most of the fuel, the fish they catch is spent on the fuel cost itself. Now, which doesn't directly affect them, but as an industry, you know that the transport or the shipping industry contributes about 2% of global emission. This shipping means inland and sea-going both, and of which the overall global fishing sector is a significant part of it. Some claim it's almost 0.5 to 0.5% of the total emission. So this is the problem we are trying to solve by addressing or presenting this solution. Now, what are the state governments and central governments do? So they spend a lot of money in subsidies, schemes, and other things. Most of the subsidies spent on, one is a boat building subsidy. So they give money for getting the boat. Then they spend on the OBM, the outboard motors subsidy. So which is why that 9.9 cutoff is there. So there's a 10 HP cutoff. So 9.9 is what all these OBMs sell. And then there is a fuel subsidy. So there is an annual, so depending on state, each state has a different number. So it could be ranging from 30,000 to 50,000 fuel subsidy. So this is what in total what they are doing. For example, state of Kerala is about 300 odd crore, which is the 5th largest state in terms of fishing. So this is the numbers. Now, what they need when we say solar fishing boat, what they need is something which still runs at 6 to 8 knots, a boat which runs at 6 to 8 knots. And 8 knots is important because after they make the catch, they have to quickly reach the shore to get the right price. So which is why they have two modes, more or less. Cruising mode is around 6 knots. And once they get a catch, they need to go high speed. So it's an 8 knots for them. And then this has to run 5 hours, which is 4 hours of cruise and 1 hour high speed mode. And the critical requirement for them is, can this operating expense of 3 lakh be significantly reduced? So that's the, that is a question in any solution. So when we say solar electric, it has to meet all the above needs. And that is how we are trying to make it happen. Now, when we see from a life cycle cost or total cost of ownership, the capex we mentioned is about 3 lakh, and then every year is a 3 lakh per year. So what it adds up in 3 years is about 12 lakh. So what that's the cost of for the fishermen today in terms of capex and the fuel. Now, if we are offering a solution, it has to be something which breaks even in 3 years, right? So that's the target we are keeping. So unlike many solutions proposed in the market, what we try to do is identify the price for it to work. So what we realize is, if it has to work, the price has to be under 10 lakh. So this is not easy. So we arrived at the benchmark price for a solar boat, keeping this in mind. So the economics for the fishermen is the most important thing. A very critical point to think is the government, what the subsidy they give in the boat building and the fuel for the life cycle of this boat, which are about 20 years. This is almost 10 lakh rupees. So if at all government thinks that, okay, whatever I am giving the life cycle subsidy, instead of giving in the 20-year period, can I give it upfront? If that happens, that is a best case scenario, then the boat will practically come free for the fishermen. But again, we are assuming that the government will not do, because most of these scenario, it will take some time for the government to do. But this is a very important sector for them, so they are likely to do. If that happens, then it's a very good scenario where the fishermen will start making money from day one and have no cost. So that's a ideal scenario. But even in the scenario government do not intervene, our aim is to, can we give the boat at 10 lakh? This is what we set aside. Now, what we done earlier, so this has been a couple of years in making, as in we have done this project 2012-13 on the first experiment we started on taking an existing boat in Gujarat, which are called Pilanas. These are 30-foot boats. Retrofit the boat into solar electric and understand how things work. So what we did, we learned few things on that the boats are heavy, and then the nature of fishing, then the importance of not having too many pillars and few other things, and the stability angle. Few lessons we learned, and finally we realized that the boats have to be slightly different in terms of, one, the shape has to be very efficient. So, and then it has to be very light. So it can't be the steel or wood, it has to be GRP. And it cannot be by, like the fishing community has already adopted GRP in a way that you take plywood and then layer GRP or fiber, but that's still heavier. So the boat has to be much lighter and the design has to be very good. Now, one reason why the design is not good as an industry is because The industry is very fragmented, small players build, so no effort in design. So this is a context from a design angle. Now, within India, in every state and within a state, within a cluster, there is some differences in the nature of operation and the nature of within this size of this 30-footer. People have different ways of using the same product. So there is a diversity of design. And fishing community, if anyone is familiar, they also know that it is very difficult to get a product into the market, or adoption is very, very difficult. More or less, you have to handhold, pilot, demonstrate the benefit. But the flip side is, if it works, then it will be followed en masse. So if you are able to show one boat which works and make money for them, then all the boats in that cluster is going to shift, and that will spread very quickly into other clusters. This is the nature of the industry. And because of that, we are trying to develop 6 different designs within this itself. There are 6 different designs we are attempting. Now, these are, we are trying both monohull, catamaran. Typically, catamaran is better because of benefits in having a larger area, deck area for fishing, plus much more stable, better powering characteristics. Maybe easier to beach also, because once the boat emerges from water, monohull loses stability, but catamaran can still be more stable. But there's a difficulty in beaching. So we are doing both because there will always be some people who are slightly more reluctant to shift to a totally different kind of boat. So we are trying 3 catamaran, 3 monohull, and within them also slightly different sizes and layouts to suit the whole region across India. So we are making 6 different designs. So what we realized is, if we were to do this, it's a lot of product development effort, and we arrived at a budget for these product development and making this pilot and giving it to the fishermen for trying it out. So thankfully, Shell Foundation, which is an independent foundation who's based in the UK, whose primary mandate is to serve the low income community, which the fishing community rightly fits in. Plus, it's also a clean tech product because it's eliminating fuel. So these 2 reasons, the Shell Foundation has decided to support us with this 1.5 crore grant, and that is how we are able to develop these designs. Now, there is something called scale effect. So when I said that target is 10 lakh, today, if you are making this spec, the spec is not small. When you need a reasonably large battery size to meet the functional need. Plus, you need motors, which are expensive now. But few things we are doing to achieve this. So what we have set out is, by the 100th boat, we will achieve this 10 lakh figure. But in today, the earlier boats will be about 20 lakh per piece. So there is some gap between the target cost or the target price and what we can sell to the fishermen today. But we are still keeping the 10 lakh, and this gap within this 100 boat is about 350 lakh, which is what we are hoping to get support from similar foundations. Shell Foundation itself, if it interests them, plus any other such similar organizations who can help in this the gap funding. So this is something which is what we are attempting to do. So after the 100th boat, it is still economical on its own. But the key the assumption is there is no government intervention. If anything happens at that time, then it is much earlier or much better. Another element which drives cost apart from scale is the indigenization. So except the lithium cells, which unfortunately is not in India, everything else is indigenous. So even the electric pod or motors, which I will show you some of the pictures, the typical electric pods, 4 kilowatt, 6 kilowatt, is about 4 lakh landing price. So that we need 2 of them to achieve the redundancy and powering. So, but this we are trying to develop here along with some EV motor maker. So it's now in testing stage. With that, the 4 lakh can come to less than a lakh per piece. So these are some things which help us in achieving this 10 lakh probably earlier than what we think. Now, an important aspect in any adoption is this financing. Now, there is a 7 lakh gap between a typical boat and a solar boat. And this has to be done by either an NBFC or one of this, which we are trying to do. Now, one bottleneck is the SURFACE Act, which prevents boat industry in general, not just fishing, to have the same benefit like auto industry. So that there is some policy measures to take it or modify it to include boats as well. If that happens, the financing is slightly more easy. And then from a design perspective, there are these monohull catamaran, all GRP hull, aluminum superstructure, flexible solar panel for this safety element. These are the two broad designs which we are working on. Then from a battery chemistry, we are trying to make it modular so that it's a 3.5 kilowatt hour modularity piece. So we can just scale up the size as and when required. It's an LFP chemistry we are choosing because it's safer. And then this OBM, we will show you that the indigenous OBM also is a role in the development of technology. We use twin outboard motors. Normal is petrol is one, but we always believe in redundancy, reliability, especially when you're giving a new technology. So twin motors, flexible panel. There is also a small wind power also to generate energy during the night. And then a better operation, like even normal boat operation is in the aft side, but we are putting electric steering so that they can operate from the front, which helps in the fisherman itself. So these are some of the detailed engineering drawings and all. This is a GA. So this is how the boat will finally come out. So an important number is this TCO. How does the TCO looks like? So this on the left side is a petrol OBM, huge fuel impacts. That's 3 lakh plus difference in OPEX. Solar board, obviously the energy cost is very low. So that is a difference in life cycle cost, which means it's just a financing game for them to get this product in success. And these are some stages of construction, just to show you the monohulls and catamaran in stage. On the right side is this pods or the OBM, which we are testing now. So that is how, and these are the motors, the battery testing is going on. So these are just to give a quick idea on the project. This is just to showcase our previous experience and capability in building India's first solar ferry and a few other solutions after it in terms of defense high-speed project, the leisure boats, etc., which all helped us to arrive at this fishing boat where the price is more sensitive. So it's like reducing the technology from this ferry, but still keeping the safety more than EV plus it is, so that the economics work. So that is what we were trying to do. This is our team. So just to understand the variety of experience which goes into making this work and a large team of engineers who work on it. So if I can take questions on this, please go ahead. Thank you.
Yes. Thank you, Sandip. That was a power-packed presentation. So much information in such a short time. Those who have questions, could you please put them into the Q&A panel so that we can address them with Sandip. Okay, I have the first question. Is from Shirosh Prakash saying, what do you think about the weight margin on the boats, the ones which is solar powered and the ones with normal propulsion motors?
So from the boat, existing boat is heavier. So it's almost 50% more heavier, because it is, if it is wood and steel, it's almost twice as heavy. But most of the fishing community has adopted the plywood plus GRP, which is slightly lighter, but not as light as GRP itself, pure GRP itself. So there's a 50% benefit in weight. Yeah, so it's almost a ton you can save. There is a difference, yes.
So that in itself will reduce the energy requirements.
Yes, correct. And the hull form shape is very crucial. A very good hull form shape helps. Now, as I mentioned, no design effort goes into the small fishing boat. It's just what somebody has done maybe 100 years back. The same thing is being built, just copied and replicated. No improvement in design. That is because it's very, very decentralized, small players building. No design houses have put their time and effort in it, which is one reason why there is a hull form efficiency. Also, there is a 20 to 30% gain in there as well.
So that in itself will also save them costs. Correct. So the next question for you is, what is the alternative considered for sailing solar powered boats during the monsoon season?
So using solar power boat during the monsoon, right?
That's right.
So these are daily daily catch. I mean, they go daily, right? So if there is no sun, you can charge from the grid. You can use a shore charging. So typically the batteries are sized for their day operation. So if you have sun, use the sun. If not, use a grid, which is still much lower cost from the grid, right? What you get power from the grid is about 5 to 7 rupees. But what you get power from diesel genset, if you have put, it's about 30 rupees. What you get the same kilowatt from an OBM, petrol OBM, is almost 40 rupees. So that's a spread in the cost of power, and which is one reason why the OPEX is so low.
Right. Excellent. Thank you. On the same subject, this question, you mentioned that the battery is modular. So this could also be taken ashore
Yes.
and replaced with a fully charged one.
Correct. This will work when there is a scale effect. When in the same cluster there is a lot of so that the modularity is kept in two things in mind. One is an eventual shift to as a renting model. Two is the same batteries can be used for the fishermen at the home for the power and other needs as well. So just carry one of these modular battery, use the power for home as well. So the same thing acts for the whole life cycle instead of just being in use when the boat is in motion, right? So the asset utilization is slightly better if you do for multiple purpose. So that's the reason why we are going model.
Okay. The next question is from Mr. Dasgupta. Any timeline envisaged for market realization?
Yeah, so the first 5 or 6 boats will be in the fisherman hand by November, December. They should be starting to use.
Right.
And we already got some of the preliminary inquiries and orders from 2 states, but we want them to we want to take the further discussion until the boat hits waters and the boat is actually running. So that is when finally seeing is believing, right? So November, December, it will be we will be taking orders to deliver. So first 100, as I mentioned, we are trying to cover up some viability funding, etc., to achieve it. Else we will just delay our when we make money, and maybe 200, 300 is when we will make money. With that risk we are trying to play. We will take orders by end of the year. It will be fully commercial. All these individual technologies are already commercial. We are not deployed as a solution commercially. Of course, there will be some feedback when the boat is in operation from each cluster. Some tweaking might be needed, but the large design element will be covered by the 6 combinations is what we feel. So we will know by November, December whether what I say is fully correct or some corrections need to be done.
Okay, thank you so much. You mentioned about wind assisted
yes,
support. So that would basically be charging the battery using wind assist.
So there are two times when these fishermen go. One is they go either early morning and come by afternoon or early evening, or another group may go in the late afternoon and come by night. So there will be some period when you may not have sun in both cases. So we are trying to put a small wind assisted. It's a small one only to begin with. We are trying to experiment if that same wind can be used for propulsion, in the sense not going the electric route, but from a thrust route, which is like some kind of Flettner rotors or suction sails, right? Those type on a small scale, but that we are not doing on this first 6 boat. That is still on a very, what you call as a land-based testing mode only. It may take a year at least, but that's an eventual goal. That might be even better than converting to electricity and coming back, because you still lose some 30-40% energy there.
Right.
Instead do directly in thrust.
So one question on the safety aspect. How do you ensure that the fishermen are aware of what is the time in hand? You know, it's like an aircraft with its fuel tank, or for them to ensure that they can safely make it back with the charge that they have on their propulsion.
Okay, so one clear thing is, like in our dashboard, there's a clear information on the range, All those things are there, how long it will go and what speed. So they will see, the critical thing is this is designed for their typical operation, 4 hours normal running, 1 hour high speed mode. And that high speed mode is when almost 40% of the energy is.
Right.
So in case they are doing more than 4 hours, they have to stay there for 6 hours, 7 hours. The only difficulty they might have is they may not be able to take the high speed mode with,
Right.
and they will have to take a normal mode and come back. So then the whole thing will increase by 30-40% more as in running time. This is one way. This is assuming we don't add another source of energy. Now, if you are able to wait, assume they don't see the display, their display is damaged for some reason. The other alternative is you wait to either charge by the sun or by the wind. Both are available depending on, wind is always available. Sun anyway is available only in the day. So you may have some source to at least come back. The third possibility is, in the eventuality of further redundancy, you may want to add a very small genset in the eventuality, but that's another cost for the fisherman. So typical fisherman may not consider, but there is within this group, some people are there who put 2 OBMs, who are slightly add more technology into it. They may think of adding a small genset for emergency. This is possible.
Okay. So the hybrid version.
It's a hybrid ready. So you just have to add a small genset.
Right. One quick question on your choice of outboard motors. Have you considered inline shaft?
So in these 6 boats, one is inboard. Mostly, I mean, that inboard works for people who are always going from the river to the sea, from estuary or sheltered water into the sea. But
Right.
many fishermen want to beach the boat, so they need outboard motors. So that's why it's a 5:1 ratio there.
Okay.
All combinations are there. Inboard is there, outboard is there.
Right. Which means you will need to have a very good sealing system for the electricals.
Yes.
Okay. There's a question from Mr. Baiju Vijayan, who would wish to know about the price of the first commercial release.
10 lakh. 10 lakh is a price. That is what we are kept the price.
Okay. And we have a question from a budding naval architect. Could you give some advice to new naval architects who want to get into research and development in marine design and engineering?
There are so many avenues. But as a biased entity, I will tell you either start a venture or join a startup and help them in their research. Like us, there are many organizations who do a lot of development, not pure research for some abstract concept or something much further down, for research to immediate commercial product. There are many companies like us. In marine, I'm sure there are still many more like us. You join one place, you will know end to end, because we have, when we are developing a solution, it has to cover entire spectrum, not just naval architecture. You need to have electrical, mechanical, fluids, so many areas you should know, and ideally an engineer should know multiple domains, not just single. So yeah, you should join one solution entity where you will have a broader perspective than do a research in one specific narrowed area, is my just suggestion.
All right. That's it with the questions. Thank you so much, Sandeep, for your time and your very insightful presentation.